Okay, today's integral, we have the integral of x to the 12th power over x squared plus 1. And that looks very scary, the x to the 12th in the numerator, that's weird. But what we can do is subtract 1 and add 1 in the numerator. And that's just adding 0 equivalently, so that's completely fine. And so we will have x to the 12th minus 1 over x squared plus 1. And by integral properties, if it's just a plus or minus, we get to separate that integral. So we're just going to add to that 1 in another integral itself. So this integral we'll save for later. This one's not that bad. But this one now, because that plus 1 minus 1 we did, we could factor this. That x to the 12th minus 1 is just a difference of two squares of x to the 6th. So x to the 6th plus 1 and minus 1 over x squared plus 1 still. And now we're going to want to do a difference of cubes, or a sum of cubes, I should say. So the x to the 6th minus 1 and that x squared plus 1, both of those will stay the same. But this x to the 6th plus 1 we have, that's the same as x squared plus 1 times x to the 4th plus x squared, or no, that's a minus x squared, my bad. And then just plus 1. And now we have, nicely, we have an x squared plus 1 in both the numerator and the denominator, so those will both cancel. And what we would want to do now is just combine this x to the 6th minus 1 and x to the 4th minus x squared plus 1. That would take a long time, or just a lot more time than you want to spend, so I'll save you that time. It's x to the 10th minus x to the 8th plus x to the 6th. And it's just adding and subtracting all of them down until you get down to minus 1. So we'll have x to the 10th minus x to the 8th plus x to the 6th minus x to the 4th plus x squared minus 1. That's a lot. But that's actually extremely easy to integrate, not that bad. It's just power rules. So we'll give us x to the 11th over 11 minus x to the 9th over 9 plus x to the 7 over 7 minus x to the 5 over 5 plus x to the 3 over 3 minus x. And that's not the whole thing, because we still have this integral from before, the 1 over x squared plus 1. But that's actually really easy too. That's just arctangent of x. And if we put our plus c on the end, that is the entire thing. Extremely long answer, but not that bad to do.